Hello, good afternoon, ladies and gentlemen, and dear professors. First of all, I would like to thank Professor Kurishima to invite me to join you online to this great conference, the 13th International Webinar on the Controversy in Glaucoma. And in September, we have a great, well-organized conference in Shantou in September, the EPMA conference. And it's a great experience for me and to learn the prevention method for the medical disease and also systemic disease. Prevention is definitely the best way to treat any medical disorder. So today I would like to share our study on the diagnosis of glaucoma, POAG. So shall I share my screen? Okay. So my topic is about the multi-dimensional imaging module for screening of POAG. I have no financial interest to declare in this presentation. Primary open-angle glaucoma, POAG, is the leading reversible blinding disease globally. And the glaucomatous damage include typical changes, including the retinal fiber layer defect, also damage to the optic nerve head. And before visual field defect developed in POAG, at least 40% of the retinal fiber layer was damaged. So early diagnosis of POAG is very important to prevent any damage to the IFL and optic nerve head. And the challenging in POAG screening, including when POAG complicated with myopia, this makes POAG, the diagnosis of POAG, more difficult in myopic patients. And also for large-scale screening, we need more glaucoma subspecialists. This is also another challenge for POAG screening. And deep learning is a class of machine learning algorithm. Now it's widely used in many fields, including medicine. And the self-trains and discovers inherent rules from large amount of unlabeled data. Now it's widely used in many image recognition, natural language processing, and other fields. And deep learning for glaucoma screening, now mainly based on, there are many studies on this field. The study mainly based on fundus photo, OCT, and visual field, etc. Nowadays, most of the glaucoma deep learning models are mainly based on one models. That is, they use only one investigation for the screening of glaucoma. And field study use more than one models to develop multi-dimensional model for the screening of glaucoma and demonstrate that the performance of multi-dimensional model have better performance than a single model. So the multi-dimensional model have the potential to have a higher diagnostic accuracy for the screening of POAG. However, so far there are only few studies based on structural changes in fundus of the glaucoma patients. So the aim of our study is to use multi-dimensional POAG screening models based on a deep learning algorithm using pair fundus photograph and OCT image. And then we also explore its feasibility in POAG diagnostic screening and applicability in myopic population. This is our inclusion criteria and exclusion criteria. We recruit adult patient and normal subject, and we use serious OCT to scan the fundus, and the OCT SNO score should be more than 6. And we also exclude any other disease that may cause retinal changes, optic nerve changes. So we involve 545 eyes from 289 healthy subjects and 509 eyes from 257 POAG subjects. All the subjects receive visual acuity test and refraction and intraocular pressure measurement. And visual field, we use Humphrey field analyzer. And the fundus photo, we use TopCon TRC 50DX from Japan. And we use Cirrus HD OCT to scan the retina. For the OCT scanning, we use the optic disc cube 200 x 200 mode to scan the IFL thickness, also get a deviation map. For the scanning of macula, we use the macular cube 512 and x 128. Use this mode to scan the GCIPL thickness and get the deviation map. And we also combine the deviation map of macula and optic disc to get this panel map of the fundus, get this deviation map. And for the fundus photo, we use the TopCon TRC 50DX, and we use the angle of 45 degrees. And the picture, the photo will center on the midpoint between the optic disc and the macula. For the image processing, the image were unified using the 299 x 299 pixel size, and the pixel values were scaled to range from 0 to 1. And the dataset establishment, we use for each subject, the following 4 images were used to input the deep learning architecture, including the GCIPL and IFL deviation map, IFL thickness map, GCIPL thickness map, and fundus photo. And we divide the dataset into training set, validation set, and test set at the level of participants. For the deep learning algorithm, we use 4 convolutional neural networks, including inception ResNet, exception swing-based patch 4, and inception V3. And each type of the image will be trained in each of the model. And softmax were used to output the probability in each model. For the development of deep learning algorithm, the model ensemble technique was used to combine 4 basic CNN models to get the ensemble models, including the fundus photo model, GCIPL thickness map model, GCIPL IFL deviation map, and IFL thickness map. And the back-end mean fusion technique was used to develop the multi-dimensional models, including the following 5 models. This is the method, the flowchart of how we develop the deep learning algorithm. For the statistic analysis, we use the SPSS 19 version, and MacCal, and 6 diagnostic metric was used to evaluate the performance of the models. And the heat map were generated using the breakcam. And to study the POAG with and without myopia, we divide the POAG patient into myopic group and non-myopic group. For myopic group, we further divided the patient into mild, moderate, and high myopic group according to the refraction. This is the characteristic of the subjects. And for the gender and the age, there are significant differences between the normal group and glaucoma group. And this table shows comparison in the test data set. We compare each model, including a single model of fundus photo, GCIPL IFL deviation map model, GCIPL IFL thickness map model, and combine GCIPL IFL deviation and thickness map model, and combine fundus photo and deviation map, fundus photo and IFL map, thickness map, and fundus photo, and finally we combine all the models together to get the fundus photo, GCIPL IFL deviation map, and thickness map. And we can see that when we put all the model together, the performance of the model with the triple model, the multidimensional model have the best performance compared with the single model or dual models. And this is the ROC curve for each model comparison in the test dataset. You can see that the curve in the blue color is the combined model, combine the three models together, we get the best performance, and the dual model also have better performance compared with the single model. And this is the heat map from the multidimensional algorithm. We can see that the area of interest in all the heat map is consistent with the area that we use for the diagnostic of POAG in clinical practice, including the optic nerve, the area around the optic nerve, around the macula, and also the lower part of the retina shows more interest compared with the superior part, which is also consistent with the POAG manifestation. For comparison of myopia and non-myopia POAG patient, we can see that in both groups, both the non-myopic group and the myopic group, the multidimensional model also get better performance compared with the dual model or single models. And we also compare the patient with different degree of myopia. In mild and moderate myopic group, the multidimensional model show better performance compared with the other models, although the improvement is not that obvious compared with the high myopic group. In my high myopic group, although the performance is a little lower than the mild and moderate myopic POAG group, but the multidimensional model show significant improvement for the diagnostic accuracy and sensitivity and specificity compared with the other group. So the discussion for fundus photograph, we can have a direct visualization of the retina and the fundus, and in this way we can review the neuroretinal ring thinning, or we can see whether there is IFL defect or whether there is any optic disc changes in the fundus photo. But it is difficult to detect some IFL defect in a very small pupil, or when there is any optical media opacity, like in corneal opacity or cataract. And OCT, it can overcome the optic media opacity, and it's also a very useful tool to detect the early glaucomatous structural changes. But the limitation is that the retinal changes may influence the accuracy of OCT measurement and increase the diagnostic accuracy for POAG, like in myopic fundus, when there is changes in the vessel orientation and the distribution of IFL thickness may also have an effect on the diagnosis of POAG based on OCT. So for multidimensional imaging modules, we combine this investigation together, we can get an objective assessment and visual information and compensate for the limitation of OCT in assessing the optic disc, linear hemorrhage, and vascular changes. That is the information we can get from the fundus photo. When we combine the investigation together to get a multidimensional model for the diagnosis of myopia POAG, you can also get better performance compared with a single model, because in myopia patient, the fundus changes like optic disc distorted or tilted optic disc, and whether there is or there may be a vascular changes, like the direction of the vessel may change, the curve may change, angle may change, and the IFL distribution may be different from a normal non-myopia patient. So this makes the diagnosis of POAG difficult. But combined with the fundus photo and OCT, we can get a better performance from the myopia POAG in the multidimensional models. So in conclusion, multi-dimensional imaging model integrate data from fundus photo and OCT to provide a more comprehensive picture of the characteristic POAG. And this will facilitate a better diagnostic accuracy in POAG patients, particularly in myopia POAG patients. And multi-dimensional imaging model based on deep learning algorithm using paired fundus photograph and OCT image data can have a higher diagnostic accuracy compared with unimodal models. And when even POAG complicated with myopia, and this multi-dimensional imaging model also have better performance compared with other models. So I thank you and best wishes for the conference. Thank you.